Hi everyone, I am Rajitha, working as Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Technology. Today, I am going to present the topic Backtracking the N-coin problems. The N-coin problems are one of the most famous problem in computer science and mathematics. The objective is to place n coins on an n into n chessboard in such a way that no queen can attack another queen. This problem helps us understanding an important algorithm technique called backtracking. Backtracking is widely used in solving puzzles, optimization problems, artificial intelligence and decision making system. Let us first understand the challenges. The goal is to place n queen on an n into n chessboard. No two queens should be in the same row and same column or same diagonal. A queen in chess is very powerful because it can move horizontally, vertically, and diagonally. This means every queen creates a thread zone around it. When placing a queen, we must ensure that it does not attack any previously placed queen. Finding such as arrangement becomes increasingly difficult as the value of n increases. A historical puzzle. The n-coin problems has a rich history. In 1848, the German chess enthusiast named Max Bessel introduced the 8 queens problem. The challenge was to place 8 queens on an 8 into 8 chessboard without attacking each other. A few years later, the famous mathematician Carl Friedrich Gauss studied the problem and confirmed that there were multiple valid solutions. In 1869, the problem was generalized from 8 queens to n queen on an n into n board. Since then, it has become a classic problem used to teach algorithm design and problem solving techniques. Visualizing n equal to 4. To understand the concept better, let us consider n equal to 4. This means we have a 4 into 4 chessboard and 4 queens. There are only 2 valid arrangements where all 4 queens can be placed safely. In both solutions, no queens attack another queen. These solutions show that finding the correct arrangement is not always straightforward. Many placements fail before we finally reach a valid solution. This is why a systematic approach such as backtracking is required. And then what is backtracking? Backtracking is a problem solving technique that builds a solution step by step. The first step is build. We place a queen on the board. The second step is check. We verify whether the placement follow all constraints. The third step is backtrack. If the placement cause a conflict and no further solution is possible, we remove the queen and try a different position. This process continues until we either find a valid solution or explore all possibilities. Backtracking is often described as trying, checking, and undergoing. How backtracking solve n queens? Backtracking solve the n queen problems using a row by row strategy. We begin by placing a queen in the first row. Next, we move to the second row and place another queen in a safe position. Before placing each queen, we check whether it conflicts with previously placed queen. If a conflict occurs, we immediately reject that position. This helps us avoid unnecessary calculation. The algorithm continues recursively until all queens are placed successfully. By removing invalid choice early, backtracking greatly reduces the search effort. Algorithm in action. Let us see how the algorithm works. First, a queen is placed in a safe position. Then the algorithm moves to the next row. If a valid position exists, another queen is placed. Sometimes we reach a point where no safe position is available. At this stage, the algorithm backtracks, it removes the most recently placed queen and tries another position. This process continues repeatedly until a complete solution is found. The algorithm systematically explores all possibilities while avoiding invalid paths. The power of pruning. One of the biggest advantage of backtracking is pruning. Without pruning, we would need to check every possible arrangement. For n queens, The number of possibility growth extremely fast, approximately n factorial. The brute force method becomes impractical for large value of n. Backtracking remove invalid branches as soon as conflict or detected. As a result, many unnecessary calculation are avoided. This significantly reduce the search space while still guarantee that all valid solution can be found. Beyond endpoints, the same backtracking technique is used in many real-world applications. One is constraint satisfaction problem. Another application is AI and game development, and the pathfinding. Next, we conclude. The endpoint problem is a classic example of algorithm problem solving. It challenged used to place queen on a chessboard without conflict. The problem was first introduced in the 19th century and continues to be studied today. The backtracking techniques provide an elegant and systematic way to find solution. This is the mind map for backtracking endpoint problem. Thank you.